Okay, so you can start. And uh, good morning. Yeah, for me it's actually good afternoon, but for all of you, so good morning, everyone. Yeah, my name is Nikolai Rosnachenko, and in this talk will be devoted to the task, which is called the sentiment attitude extraction. But before beginning with this task, I decided to split my presentation in two major parts. So in the first start, we are going to go to the very beginning of the sentiment analysis as a task in order to better understand and demarcate our one task with the other already existed. And in the second part of my presentation, I'm going to provide the details onto the resources that we implement in order to perform investigation of this area and the related results that we obtained. So let's get started and actually move back to the, I guess, more about 18 or 20 years ago, where some aspects that are very obvious for now become more or less clear. So at this point, I mean that at that time, it was more or less clear the significant growth of the information and the constant growth of such information year by year. Especially in terms of the textual information, we can demarcate those type of texts and messages where author shares his opinion onto object mentioned in text. So the task which is devoted to extraction of such opinion is called sentiment analysis. So it's not occasionally appearance of this image on the screen, as it illustrates the simple case of such text. So usually it's user reviews towards the product or services. And especially if we're interested in this task, and due to the significant growth of the information, of course, there is a need to perform that automatically, to perform this automatically. And this leads to that we need a certain levels of this analysis. And the first level of such analysis was proposed as text classification. It was proposed, one of those who proposed this was the Peter Turing in his paper, Thumbs Up or Thumbs Down, Semantic Orientation Applied to Unsupervised Classification of Reviews. It was proposed as follows. We have a document, and for a particular document, we need to provide the related label, which can be positive, negative, or others depending on this task. For the particular example, we can see that it's positive because the camera has great quality. But at the same time, we see that there are a lot of information that remains unspoken to the mathematic algorithms, especially the fact that we are interested in camera and that actually camera is amazing. This affects the way that we have a certain restrictions and limitation in the task. So we need to guarantee that we have a single object and the single opinion of the author towards this object. But text might be even larger, and this leads to the more entities in text, which brings me to the next level of the analysis, which is called the targeted sentiment analysis, which brings the entity onto the input the parameters. So we have an entity, and in the related example, we now can say that we have the sentiment attitude towards the camera, but for example, the tripod, which is another entity in the text, we don't have such opinion which is related to this object. So this partially what makes this task more complicated. Another level of the analysis then leads to the domain which is called aspect-based sentiment analysis, which focusing on the two measure tasks. So the first one is to extract the characteristics according which we may reveal the presence of the sentiment opinion. And another one is assess this, extract the sentiment by relying on this aspect. In the particular example, the picture quality is such aspect. And considering the picture quality and assessing the camera, we can conclude that we have the positive review because the picture quality is amazing. Finally, that brings me to the definition of the opinion, which is provided by Bing Liu in his survey and another paper, which is called Sentiment Analysis and Subjectivity. When he proposes the opinion as the statement in aspect-based task, but extended with additional parameters. So it could be author. Now we have multiple authors, and we have a time parameter. So the case of multiple authors means that in some texts we may cite or quote somebody, and this means that it's not our own opinion. So we refer to opinion of the other person cited or quoted in text. And as for time, it means that it could be mentioned in the past, it could be referred to the past, or it could be referred to the current events. At this moment, I'm going to say that mostly, and now we are declare all the analysis which assumes that the source of opinion is an author, but in general, it could be not author. And if we switch the author towards the object mentioned text as a source, that leads to not fully and just slightly discovered area in which we now deal with the opinions with where a source of the opinion is object and the target so an object. The question you might ask in this case, where we can deal with such case and scenario. At this point, I'm gonna talk about the specific domain of the text, which is called the analytical articles. These are the domain of text where author shares his opinion onto multiple objects mentioned in text. And that leads to the effect is that objects itself become a source of opinions. And analysis of this text is called, we called in our research as sentiment attitude extraction. And then just instantly go to the example in order to better understand such cases. In this particular example, we can see that we have two named entities. And while author provides his opinion by analyzing Washington and Russia, it from this context leads that Washington has a negative attitude towards the Russia just because the mention of there is no place for objectivity on the subject of Russia. So in order to conclude once again, so we in our research we're focused on the analytical articles, which are more larger, of course, than reviews and even larger than news articles. What are the other issues and problems that we are encountered with while we start investigating this area? They are as follows. So the first I'm going to mention is the problem of the representation of entities in a variety of forms, which means that we, let's say, may encounter with the Russia or Russian Federation, or the shorter version is RF. It leads to that we need to resolve the coreferences and to deal with the coreference task. Another problem that we encountered with is, of course, the complexity of the structures. As for the example on this slide, we can see is that the Donald Trump has a negative attitude at the same time both to the China and to the Russia. As for methods, in order to start and initiate the research of this domain, we're focusing on the application of machine learning methods. So the general idea which stays behind the application of such methods is that if we would compare the natural languages with the artificial one, such as programming languages and many others, problem is that in natural language we cannot provide the grammar which could describe any case and any scenario in which we could convey the opinion in text. So it means that any type of rules that we could provide for the analysis can cover all the cases that we can encounter with. So as a solution, to address on this such limitations, we use the machine learning methods. The general idea that stays behind the machine learning methods is a need in labeled data. So for a particular example, so in our case, it's a text with an opinion. We need to provide a particular label. And we treat these methods as algorithm in which we have a certain black box, which we, as to say, train and provide the examples for which we have the particular labels. So I'll proceed with this in more details later, especially as for methods. So as I said, we need the data set and we needed separation in the data set, separation of the documents onto train part, which we use to train our model, and a test part, which we utilize for model evaluation. And that brings me to the first step that we apply in our investigation of this domain. So we manually developed the collection. It consists of 73 analytical articles, and the labeling was provided in following direction. So let me start with the second one, which is called named entities. So named entities were provided and labeled automatically, and additionally were checked by humans, experts. And another labeling that was provided and was based on these entities are text attitudes. So these are triplets where for a particular subject is a named entity towards the object, we provide certain label. So we are focusing on only a positive and negative assessment. It was also, at first, we were also interested to use author as a source, but at the present time, the labeling is quite low at this point, so we cannot initiate research in this direction. And as for coreference resolution, we provide the list of the synonyms, so it's also was manually implemented in order to not deal with the coreference task. So that was the certain limitation in our case. And every document after it, you can present in the form of a graph where nodes corresponds to the mentioned named entities, and arrows represents the document level opinions in it. As for statistics, once again, we have 73 large analytical articles, which were separated onto train and text collections. And as you can see, the texts are quite saturated with the amount of sentences and, of course, amount of attitudes. And moreover, the amount of the mentioned named entities in it. And if we summarize our say, the developed collection and application of the methods towards this collection, we may treat this task as opinion extraction, but with the certain limitations. So the limitations are, say, drawn in the gray of color. So we don't have an aspects. We considering a single author, so we're not focusing on the quotes and citations of mentions of other authors, and we are considering the present time. So we're not focusing on the events that were in the past. And let's back to the methods that we apply. So there were two major directions, where the first one is the conventional methods. Another one was the neural networks. And within this presentation, I'm not going to dive fully into details, but I'm just going to say that we can, with certain limitations, treat neural networks as like non-linear optimizers for everything, which in general seems to perform better rather than conventional methods. While the disadvantage of this is the complexity of the training process. And that brings me to the question that you may ask, so how we can then, for a given data set, provide the input for such models. So this input could be organized in two different formats. So one of these formats is a feature-based method, which assumes that for a particular pair of entities, we collect the vector of features. And another one, which is applicable for neural networks, is that we extracting the related sentence that includes a dimension of a pair of entities. So let's get started with the first one. I'm just briefly provide the features that be used. So we may just for a particular entity, you can say whether it's the country or it's a capital. We can provide the frequencies of this entity. What else? We can measure the distance between two entities, amount of commas, amount of the different other punctuation signs that we can see in between the pair of entities, and lexicon based, which assume that you're already familiar with, which means that we are obtaining the scores of entries of a certain vocabulary. So all of these features, the basic idea is that they should at a certain point emphasize the presence of the opinion in text, or maybe the absence of this opinion. The second approach is to focusing on the context. So it means that for a pair of entities, we need to find their entries not so distant from each other and extract the related sentence, as you can see on this example, considering Russia and Turkey. And this also, it is worth to note that it leads to additional work, which means that we need to convert these context attitudes towards the document level attitudes, and do this vice versa, especially if we'd like to provide these examples. And finally, the first part, we experiment with the manually developed collection and separate results of the models here on the four groups, in four groups, where first one is related to Bayes methods, when we just assign everything as negative, as positive, or as random. The second group is the conventional methods. Then it goes to the neural networks, and finally, how actually humans solve this task. So let me introduce the metrics that we utilize. So precision makes it denotes the percent of the opinions that were labeled correct across all the opinions that were labeled, while recall denotes the amount of the opinions that were found in our labeling with respect to the all the opinions that should be found. And the last measure is the combination of the two of these. As for human assignation, we can say that the task was quite challenging in terms of the searching of such opinions. So this leads to the recall is quite low, just because at first, while briefly reading the article, annotators could not find all the opinions present in the context in the text. But among those that were found, the 62% of these opinions were labeled correctly, which finally results in 55% result. So among other models, I can conclude that the best results were related to convolutional neural networks. So that leads to, in further, we proceed with the convolutional neural networks. And this is what leads me to the second chapter, which is called automatically annotated collection. So here, the main motivation is the fact that the collection that we have that we manually annotate is pretty small. So that moment is quite significant for neural networks, which becomes more advanced and robust in case when we provide more data and train it appropriately. In order to address on this limitation, so our investigation started with the lexicons. So before that, you know this lexicons as vocabularies of pairs, where for every pair we have a particular label or score. But in general, and in the related domain, we're focusing on more complicated lexicons, lexicons with a more complicated structure. This structure should allow us to emphasize the present of the context. And that leads to we developed Lucent frames lexicon. So let me answer the question why, in which direction it's more complicated. So at first it provides the role designation. So we have an agent and we have a theme, and the labels that provided for every entry in this lexicon are devoted to effects and states, which is related to these roles. So for a particular example, we can take the word to approve. We have somebody who approves and towards what is approved. And we exploit the following information that someone who approves towards what is approved, it's usually a positive. And this type of information we may utilize in the text processing in order to build an assumption about the text. So finally, we have such lexicon and the related information for every entry in it. What we do next? So we apply this lexicon to the news collection. And the way of how we do this is actually called as distance supervision. So the definition of the distance supervision, I mean the term distant means that we refer to the knowledge base in order to make a certain decision about the text or context. In our case, this knowledge base is a lexicon, which was presented on the prior slide. And the main assumption that we can apply this and how we can start with the text analysis is falls onto the assumption about the news titles. So news titles usually have a simple structure of the information presentation. So it means that we can do the following thing, is to apply two different methods towards the news title processing and combine their results. And in case of we have the same results, we consider that we, let's say, double check and guarantee the correctness of our assessment. So these are two methods are as follows. One is the pair-based method and another is a frame-based. So speaking about the first one, we can obtain the related statistics of attitudes of subject towards subject from our priorly developed collection. And we use another method which assumes to search for the particular patterns where we have the first entity treated as a subject and another entity which goes then as an object. And if we have the entries of the frames in between of them with the same labels of such polarity of the adjunct towards theme, then we can conclude that the result label such scenario. The next slide provides this this idea in the form of the diagram. So we have a news collection, and we go here. Then we perform the entities annotation, and from here we can go in two different directions. So we can apply frame-based method and pair-based method in order to then perform the intersection and collect all these examples in a result output collection. Let me proceed with a simple example. Here we have a title, and I mentioned in the green box entries of the frames, where, as you can see from the title, that USA continues supporting Georgia. So continues supporting is has a positive polarity according to our lexicon, from which we can conclude that USA has a positive attitude towards the Georgia. And then we use information from the sentences. So we're looking for sentences in which we can find entries of such participants of the attitude. In this way, we can extend our labeling with the more complicated cases. So we assume that if title provides the attitude, then the text itself devoted to the discussion of this attitude. So this is the general assumption. And as for experiments, so as I said before, and according to the prior results, we stay focused on the neural networks and additionally provide research for such say modern direction of in the neural network studies, such as neural networks with attention, where attention knows the specific module that could provide word weightings in our context. So I provided details about it on the next slide. So what is actually attention? Attention is as I said, is a module that could be embedded in a neural network, and it provides us the opportunity to perform weighting terms in a context. So for a particular example, as you can see, we have a negative attitude of the particular subject towards the object, just because the entry will finally lose trust in someone. If somebody will finally lose the trust in someone. It's interesting to know that these weights were obtained automatically. So it means that being embedded this model in a neural network during training process, we additionally ask for model, could you solve please the task which finds us the more relevant words, the words that are relevant to the particular class with respect to the object, subject, and other terms mentioned in a particular context. So in this way, we can see that such words as will finally lose and lose trust in are more significant in this case, and these are words that emphasize the presence of the attitude mentioned in its context. So it's worth to know that we do not provide this information like to the model as an input, so it's just become a result of the training process. And at this point, I'm going to mention that the application of lexicon, in this case, the lexicon of frames, makes let's say improves the way of how we treat our task. So we can treat them, these frames, as aspects which we consider in our analysis in order to make a decision about the class. And then finally, it brings me to the results in case when we adopt the automatically developed collection. So at this point, I can say that we come closer to the results of human assessment. So the neural networks with attention illustrate the 42% of the both precision and by recall metrics. However, in general, it's of course these results are quite low. So till the present moment, the task still remains quite complicated. And then let's take a look at the other examples of the attention, which I would like to show, and which I, let's say, conclude as a results of the application of automatically annotated collection. So here we can 6 sentences, where first 3 are related to the results of models that were not using automatically annotated collection, while 3 last examples are related to the case when we adopt the large automatically annotated collection in training. Of course, I select more appropriate examples, such examples in which, especially 3 last sentences, we can see that the weighting is focused on the frames in sentences. And what's interesting here is that we can compare that in models that were focused on the single collection, the weights are absolutely different. So it's focused on the weird words, and at this point, the application of analytic collection shows that the model captures the whole pattern, is that that the most informative words stay in between the subject and object in the context. So that was actually pretty interesting to investigate. So it was obtained automatically. And one of the last slides, I'm going to conclude everything that was mentioned in this talk. So at first, I'm going to say that news titles, the aspects of the news title and this feature is that in most cases, it's easier to analyze them, and they are like very helpful in terms of the further analysis of the document. The same effect we can investigate with RSS feedings or maybe sort of like Twitter messages. So the case when like we have the short text yeah, maybe Twitter is not a great example, but the reason is that we have a short text and then the verbose form of it, so we can exploit the short one in order to then process the larger amount of text. The second I'm going to mention is the importance of lexicons. The latter finds its application in a variety of the sentiment analysis tasks, and not an exception in our case, which we additionally could treat them as an aspects, and it also actually in other tasks could be treated as aspects, because some words like good, bad, or I like this usually emphasize the presence of the opinion in text. Of course, it could be treated as sarcastic way, but it's related to like a different task. So in general, we can say that it could be also treated as aspects. And the last I'm going to revise is that we started with conventional methods, then to lead to the neural networks, and our further research that remains, say, out of this talk is the application of language models. So the idea behind such model is that it's usually provided in a pre-trained format. So it means that it could be applicable to a variety of tasks. And the latter means that since they were prepared on even larger amount of data, the results seems to be in a way better. And that remains our further goal for investigations. And that's pretty much out of it. So thank you for listening to me. Unfortunately, it's in the form of the video format, so that would be nice, like to give you this talk in a real life, especially if we'll have such opportunity. Yeah, but in general, so thanks. I'm gonna say thanks for watching. So that's it. Okay. If you have any questions, so
yep,
yeah, I'm ready to.
Yep.
Yeah, I'm ready to open up the tab with the chat.
It's fine. I can repeat the question. We have a question from Yasmin. Did you use the pure CNNs without the recurrent layers in your study?
Exactly. So in this slides, we provide. Let me go to this. Right. So here provided example for the pure CNN, but at the same time, I'm going to mention is that the pure CNN is not, let's say, designed for such type of task. We additionally adopt the network which is called the CNN. I'm writing like in the chart. The idea behind this network is that it could focus on the certain parts within the context. So let me show, I guess I can show the picture in order to easily emphasize, illustrate the difference between the CNN and the CNN. So, yeah, so here is this picture, which shows us is that for a particular context in which we have a mention of the attitude in it, for example, USA considering sanctions against Russia. We have the USA has a negative attitude towards the Russia. So unlike the original convolutional neural network, in which we perform the convolutions or let's say process all the context, here we treat the context in parts. So we have a part between before the USA, in between the USA and Russia, and after the Russia, and to the end of the context. So, right, I do not provide and don't dive in such details in this presentation, but in general, I can say that application of the PCNN even better results in a faster training process. So, okay, so I hope I'm not fully dive into the details, just would like to share that just we have sort of specific networks for this task.
Yep. Thank you very much. Before we have a short break, I just want to make some points and yeah, a final question. So yeah, thanks for your presentation. Very well structured, and we can see it's.
That's great that you found this in this way. So I hope that I'm managed in time. So I'm actually.
Oh yes, yes.
It seems like more about 40 minutes. So slightly took greater than 40 minutes.
Yep. So it's a very well structured, comprehensive research program for a PhD study. From the initial observation and initial studies about the text structure and how they can inform your sentiment analysis studies. And so one important point is about the text structure complexities. So in this case, the frame is applied, and there are also other kinds of linguistic theories that could be applied, but they are more complex and they may not be as effective as other approaches, the neural network approaches or other statistical or machine learning methods. And it also highlights the importance of the building up the text collection for your study and how to label the data automatically or annotate the data manually with the limited resources so that your study can move forward. I think that it's very challenging to have this kind of text collection for this specific task. And so, yeah, you also mentioned about the use of the frames and the context words in your studies. And of course, the language models is a natural extension of this kind of approach in this specific test. As you show in the evaluation results, it's still very challenging. There's still lots of room for improvement. I just have a final question then. So do you consider that the human labeling agreement is the gold standard for your study?
Well, I can say that considering this collection, it's for models simulation, we treat this as a gold standard. But there are some cases that we may treat in a variety of forms. So in some cases, we cannot guarantee that the correct answer is positive or negative. So at this point, it's quite challenging moment.
Yes.
Which is, as a result, as you can see, affects on the result evaluation metrics for humans that mostly they cannot find the opinion itself just because of briefly reviewing the article. But then when you double read this article and mention your attention to the particular case, elaborate on this point, thinking more on this, then you can realize how in this context actually conveys the presence of another opinion. So it's still pretty challenging. And as for labeling, I'm going to say that It's mostly it's a gold standard, but there are some cases that we may treat as not gold standard, unfortunately.
Yeah, sure. As humans, we have it's a cognitive process. So the agreement among the humans, yeah, is not very high. So yeah, it's that's the way.
Interesting. Yes, sorry to interrupt you, because the interesting fact here is that when I tried to implement this manually, like trying to read these articles and extract them, since I get to this after my own implementation of the context labelings, I mean that I already annotated the entities, annotated the frames within it. I found that it's even easier to perform the annotation when you have the extracted context with mentioned named entities in it and with the annotated frames in it. And after that, you realize that it's in a way more challenging to do this without such labeling. So that's what, from my experience, I found interesting moment.
Yep, and we need to build a larger test collection for the advancement of this research area. Yeah.
Yes, exactly. It's like the problem of the low resource domain. Yes, and in general.
Yes. Thank you very much.
And yes, you're welcome. So at last, thank you everyone who listening to me present the lecture. So if you have like additional questions, maybe I missed something in the chat that didn't answer, you can easily write me, or for example, ask Leo. You can redirect the question me, or tell you in a way of how you can contact with me. So thank you everyone.
Yeah, thank you.
Thank you, Leo, for the provided opportunity.
And, we will have a 10 minutes break, and when we come back, I will talk about social network analysis using the Twitter data set.
That's great though.
Thank you very much. And
it's actually referred to the beginning, like from what we're actually started, so the fundamental.
Yes. And see you in 10 minutes. Thank you.
Thank you.